All right, welcome back, everyone. We're going to cover today um, another couple of details regarding classes to get a good sense of how some of these work. We're going to work through an example, and I'm going to give you kind of an intro to what's happening. So this one, we're going to set a name, and this starts with some defaults. We're going to fill in some properties. We're going to fill in some methods. We're going to be pulling all of this information together in order to make all of this make sense. We have a couple goals that we have for this, and it can be explained simply. I'll pull up that example so that we can walk through kind of what the big picture is, so that you see an instance of a real world problem that we then need to be able to make happen. So we're going to start with setting up our naming and our properties so that we can define what our class needs to be able to use. Then we're going to go through the constructor to build what the actual class is going to be doing. Now, I could explain everything like this guy, but I just don't know how to use my hands that much.
Definition file, let's consider an example where we can see these concepts in action. Orienteering with object-oriented programming. Orienteering is a sport in which participants use a map to find their way through the wilderness to a series of waypoints as quickly as possible. With many different participants trying to find different waypoints, everyone needs a way to record which waypoints they found and when. To do this, participants carry an electronic ID stick. When they reach a waypoint, the ID stick records the visit to that waypoint. This example is featured in the MATLAB Object-Oriented Programming on-ramp tutorial, and we'll be using a simplified version of it today. We need to create a system in which participants in an orienteering competition can register for a specific course and then log their progress using ID sticks. Today, we'll be working with two interacting classes: Course, which describes a specific course, and ID stick, which will track participants' progress through the course. By the time we're done, we'll have made a basic orienteering system, all while learning the ins and outs of object-oriented programming.
So what this will do is allow us in the first instance to create the course, and that's going to have a few data types, and then the ID stick, and then we're going to need to control a little bit what the access to examples of this is. This is probably going to be over the course of a couple of different lessons as we go to build this out, just to give you a frame of reference for how we're going to make these work and how we're going to solve an example of a real world problem using this kind of methodology, so that we can create these. So the data types we're going to include are going to be the same there. So we're going to start this is going to be course, and all of the untitled 3, we're going to go ahead and leverage that shift enter to make things easier. So we're going to save this as course. Course.m. So that's always step 1. So we're going to need a couple of properties for those. So name, level, and waypoints are what we're going to need here. So this is this defines the characteristics of an orienteering course. By way of the properties below. Okay, so we have some sort of an idea what we're doing, where we're going, how we're going to get there. We're going to need the constructor. So this is going to be course. We're going to have 3 things that we're going to take in. Name, level, waypoints. So all 3 of those are properties that are going to need to be accessed. So we'll think about whether or not we need to restrict them as far as access as we start getting there. So we're not going to stick with this formula. In Dr. K's video, he said these fill out some things automatically that don't necessarily do what you want them to do yet, which is why he started with a clean sheet. I wanted you guys to see, since you would be curious, what does it do for you? Well, this is what it does. It gives you an input function and an output function, or gives it a constructor and an output function, essentially. Yeah, so it's constructor and an output function. So the 2 basic things that you need for class to be functional. So we're going to define the course with these 3 inputs. We're going to want to be able to call this, and users are going to want to, or users are going to need to access, meaning write to and read from. So set and get in the correct nomenclature, to set and get name, level, waypoints in this object. So there's a couple steps on how that gets done.
Done, we'll have made a basic orienteering system, all while learning the ins and outs of object-oriented programming. Let's dive in. The properties defined in the class.def file can be any data type and contain the necessary information about that object. In our example, the class.def file course.m contains the name of the course, expressed as a string, a level classifying its intensity, also a string, and a series of waypoints along the course, expressed as an array of doubles. These 3 properties together comprise a full description of an orienteering course. The methods of a class contain functions for the operations that can be carried out on objects of that class. In our example, we have the method checkWaypoint, which is used to track when a participant visits a waypoint as they navigate the course. When we run this function, we see a waypoint being logged by the method. So, this class definition contains a description of an orienteering course, including a list of waypoints, and a method that tracks participants and logs their visits to waypoints throughout the course. We can reference these properties and methods with dot notation, and we can currently modify their values as we please, but we'll talk later about how we can prevent users from modifying property values. Now, let's create an object based on this course class.def file. To create an object of a class, we use a constructor method. All MATLAB classes have a default constructor method, and in this case, the default creates an object and sets its properties to empty doubles. We can also create our own custom constructor method. One common reason why we do this is that it enables us to initialize the properties of the object when we create it.
So this is one of the key aspects of what this is going to be doing. So in order to set these up, I'm gonna clear clear the workspace and command window manually, just to give us a little bit of function here so that we can see what this is actually going to be doing. So name, the nomenclature is name is, this is a string type, level is a string type, and waypoints are a series of 3 coordinates. So using a simplified starting point, and there's a couple reasons why we want to define those properties this way. Part of that is to constrain data types. So this constrains the properties to string type for name and level, and array type for a double, array of doubles rather, array of doubles for waypoint. There's a few reasons why you want to do that.
A constructor method is a special method in the class, whose name is the same as the class, and whose output is an instance of the class, or an object. Let's make our constructor take in 3 inputs and assign them to the 3 properties for this class: name, level, and waypoints. An important addition we need to make to this constructor is to build in the capability for it to return an object with default property values when it is called with no inputs, which can happen automatically sometimes when it's referenced elsewhere. We can now store the course object in IDStick
So what this will do is give us an example. So course is how they're defining things. In this case, he's not doing any definition. I believe in properties, you can set them up this way. So we'll see if this throws out an error. That first method for the constructor is going to be doing what we've started here for name, level, and waypoints. And this is a very simple example of an if else if. This is something that makes code to be more robust. This is not something that we did in the previous example, but we're going to do this in order to make things a little bit more robust, because you'll always have somebody trying to interact with a function and they'll do it incorrectly. They'll give it something else. And you can use these. We're going to use lowercase in order to make a distinction here. And I believe you can leave these. So we'll see. This is going to be that part of our code is going to be experimental to see if it throws issues. Yeah, 12 should be okay. Because we're not using them within the constructor yet. Construct an instance of the course class, and this is so we check to see if all 3 arguments are presented. Then we either throw, typically this is where we start doing more in the way of like error handling in code. This is something that I've talked about and made reference to. I've tried to avoid it up until now because it adds some layers of complication, but it also adds robustness. So this is how you actually get MATLAB to throw red letters of your own, by saying, in the case of this, if number of arguments in, so number of function input arguments, n arg in, is comparable to 3, 1, 2, 3, then do stuff. Else if. MATLAB is better about automatically aligning and justifying things typically, because reasons. The else if case. So if it's different than, this is there's a couple ways to handle this. If the number of arguments is greater than 0, really this could just be an else, and that's how we're going to present it. Is I'm going to do an else with, I think in this one we can do no argument and just throw the error message, if I remember correctly. So again, we'll see if I'm wrong. It's happened a couple times in history. So and then in MATLAB speak, each of these, MATLAB speak, string is not single quotes, string is double quotes because reasons. So going back and forth between different languages can get confusing because of some of these little syntax particularities. So you either put in 3 arguments or Deadpool will come to your house. If that doesn't motivate them, I don't really know it will. All right. This is the kind of stuff you can't get on any other channel. So then they set each of these variables using the inputs. And this is what's going to be helpful. So name, level, waypoint, based on the naming scheme that you're using. We're going to say C and C.name, and we're going to take this, we're going to cut this and move it now into where we want it to be. CName equals name. C dot level equal level. C dot waypoints equal waypoints. So now we are using and storing and suppressing output and things. Otherwise, if there aren't 3 arguments, any other condition, any other thing, it's going to throw an error message. So that's a couple of the key parameters that you can pull from this. All of the ifs must have an end. But that function goes with that end. It'll show you where the end is for this one. This one has an end at 25, but that means this one doesn't have an end till 32, except 32 isn't the end for that one. So you need another end. So before this string, now we're going to untab this one so that if has an end, this goes to function C. So we now are containing that one correctly. Function has an end. This goes up to methods. This covers the whole class def. So we now do not have an end imbalance on our conditional inside the function. So either it is throwing an error or storing inputs to the properties. That's what it's going to do. All right. So we already sort of have a functioning arrangement for course. We're going to add another one, and we're going to do, yeah, it's not hugely time saving exactly to do this. It can be. What I'm going to do is another class. So this will be ID stick. Replace with ID stick all the places with the ID stick. ID stick. This allows logging of individual waypoints. Allows the logging of individual waypoints and time progression. So there's a couple things that can happen here. We're going to look at the properties and see what some of these things are and how they work.
The capability for it to return an object with default property values when it is called with no inputs, which can happen automatically sometimes when it's referenced elsewhere. We can now store the course object in ID stick as one of its properties.
So ID stick needs to have several things as far as properties, including course. This is very important. Because these have to have some interdependence, it makes sense to complete course and have that ready in order to start preparing all of the properties and all of the things that are going to go into this. So the class definition is our starting point. We set up our properties, and there's going to be a few. So there's a serial number, so each ID stick is unique, and you can define, so yeah, like I thought. You can define the size and then variable type. So I'm going to go back and make some adjustments in order to not throw some issues. I'm going to set up this and save it. It's going to prompt ID stick, which is fine. Save ID stick. What this will allow is, so we're going to have cereal, but first, before we have cereal, need to make sure that your roommate hasn't had all the milk. So you're going to have to specify a size. And yeah, because this is where it's going to throw a syntax error here. So I'm glad we're replacing this. 1 by 3. Uint 8 is fine. We don't need tons of memory for waypoints. They don't need to be, in this case, even GPS coordinates don't need to be 18 zillion decimal places. So it'll be just fine. All right. So these are those key definitions for properties. So we're going to do a couple things in this. That's what's being referenced here. Is serial, status, participant, course info, timestamps. Yeah, status, timestamps. By convention, it's sensible to have your top line properties start with capital letters because reasons. It's back to the whole establish the running game in football thing. Don't ask questions or people will throw you out of the tailgating party. So there's that. So each of these has a data type. And timestamps, I think, has to be double. There's no, this is date time. Date time is specific. There's a specific reason why we want to use that. So the rest of them are all going to be 1-1s. So serial can be a uint. In this case, uint 32 is probably overkill. Practically speaking, our modern computers have enough RAM and things that this doesn't really matter a whole lot, actually. When you get to be thousands and zillions of lines of code, then some of those things and memory allocation and total memory usage matters more than what you guys are doing right now. These are all very, very small programs relative to things like operating systems, for instance. So two string types, status and participant, and course info, which is from course. So it'll allow us to use that since course is already defined. If course was not saved and written first and saved as course.m, we couldn't put it here and have it make sense. So if we were to try and type horse, cat, dog, it has no idea what that is, but it understands that it can include course info. So properties are done. All right. Then we start filling in the constructor. And this is going to be something that makes sense. Could be S, could be capital I, capital D. There's a lot of ways to do this. Stick is sensible because ID might be too general, such that if you go to use it in another program somewhere else, it might try and refer back to this. Or you might forget that you've used it. Stick is something you're unlikely to use elsewhere for a different type of example. So this is why this is actually a very sensible product. And just in case you guys think that this is some ancient video from long ago, back in the potato filming days, this is something that was just put up by MATLAB 2 weeks ago. So this is their current best effort at trying to provide quick and reasonable examples of how to do a thing, how to solve a real world problem using objects in MATLAB. This way you guys get to see some connection with reality and how this works. So again, we're going to use the same sort of concept. So if the number of arguments is greater than 0, do this. You could do an else with an error message for error handling. You don't have to. You can just have an if end. That means if the number of arguments is 0, it skips over this and goes to the end, and then it goes to the end of the function ID stick. So it does nothing if the number of arguments is 0. It does nothing, which is not robust in terms of error handling, because if somebody just calls stick equals ID stick and doesn't give an argument, then it's not actually going to store it's not going to go get the serial number, or in this case, it's doing a couple comparators and then storing to the serial number that's being used, for all of the people, k as an index variable. It's pretty common to use I, j, and k as indexing variables because of the x, y, and z association in linear algebra. I, j, and k are going to be very common. So you'll see me kind of default to those sometimes. You'll see a lot of seasoned MATLAB programmers default to those just because it's a top of the mind thing. It's something that they can think through very, very readily, immediately come back to something and know why they had chosen that. So it's not really truly random. It's just a starting point. So we got to set up the constructor and include if the number of arguments is 0 or is greater than 0. So now we do stick and then property. We'll get here. We'll get here. All right. So stick equal ID stick. All of this. Untitled. This is the stores the ID numbers. Of all the participants. So that's the whole goal of this. So in this function, this is where we want our if. After we do our operation, we want our end. N arg in greater than 0, then do this stuff. And the way that they have this built out so fors have to end if for this one, I'm going to use I. And the indexing that I want to do for this is going to be up until there's a couple different ways that I could do it. I'm not going to use the size reference yet because that'll create some additional questions. So they're using the serial number variable here. 1, 2, yeah, number of elements. That's going to be the best way rather than size. That's number of elements is a better way to constrain this. Uh, don't think you have to include any other, yeah, numl. And the numl, we're going to have to, before we fill that out, we need to change the input arguments here. So the ID stick is just going to be the 1, and snum will have to do for what we're trying to do. So this will at least give us a pretty reasonable starting point for this. Let's see how we are on time. Yeah, this will give us a reasonable starting point. Because number of elements is going to be useful. So we're going to pull in the serial number and we're going to store that K serial number, kth serial number, and in our case, ith serial number. This is an element-wise, meaning stick at address rather than stick at address. This is really critically important to the function and robustness of what we're trying to do. Stick at I. Use serial number. And this is going to be snum at index I. Because snum at index I, we want that to be stored and built within this little for loop from 1 to the number of elements for that series, so that you don't overrun or underrun, create a compiler error as you go to run. So must be integer, must be positive. These are helpful, effectively acting like logic gates. They're a comparator of sorts, so must be integer, must be positive. Validates whether or not something is an integer, and must be positive, validates that something is positive. Okay. And those two are going to act as kind of gatekeepers to make sure that these allow you to continue to run. Otherwise, you get an error message thrown. But we've included now, of course, the next thing is going to be including the register. So there's a couple other functions that we're going to build out after the constructor here. And the register is going to include a couple more pieces. The stick that we've just defined, the name, and C, which is from our course output C. So this is going to be our register. And we're going to have a couple pieces to that puzzle. So stick, name, and C, those are sensible because stick, name, and C are, this needs the information from the above. Again, things that we talked about in kind of the prior lesson. This this coordinates the username, the participant, and the actual function itself is, yeah, it's registering essentially where they are in the course. So there's a couple pieces to that particular puzzle. All right, so with a little additional preparation here, there's a couple more things that we need to get the ID stick to do. So we are going to use serial number, we are going to use status, we are going to use timestamps, course participants. We're going to make some probably changes to arrangements and things later as we kind of develop and do some testing and figure out how to make these function in essence. So there's several things that we need to be able to do. Some of those include making sure that the ID stick has a few parameters and a couple simple examples, or a couple elements here in the constructor. Then what we're going to move to is setting up the register. This is when they come to actually do the registration at one of the events or at one of the checkpoints. The ID stick gets plugged into a computer or read using NFC or whatever the case is. So what it's got to be able to do is it's got to be able to do a couple of things. So we're going to include a couple pieces of information. Based on these, we're going to do, we're going to use stick and name this let's do lowercase ID for this. We'll cover a little bit about why later, and that means this we need to change to ID. And then C for course should be okay. So these, we're going to have a couple things that we need to do in order to register. So we do ID dot participant, and to that participant we're going to store name. We need the course, so course info. We're going to store the information from C, course info. We're also going to be doing inside of this timestamps. And there's a couple ways to present this data set. What we're going to need is we're going to need a function here that's going to get us the size of waypoints. We need the size of C dot waypoints. There's going to be a couple reasons for needing this kind of information. Status is ready. There's going to be a couple of things that we're doing here. So the ready is what we're storing to status. When the register gets run, all of this information comprises the sum total of an ID in order to make all of this work and cooperate. And we're going to do, there's a couple other pieces of this puzzle overall that we're going to have to put together. So this is a function that exists. I just wanted to show this to you. Not a time. Occasionally you will need to look at a piece of data and see if it conforms to a valid value. So they give something like year, month, day, hour, minute, or second when something in there has a value that can't be possible, right? If you're at 2024 11 23 13 12 and 50, 13 is not may or may not be valid depending on where it is in this group. So month 13, for instance, wouldn't be a valid date. So you're checking to make sure whether or not this is a time. And then based on that, the size of waypoints, this is an error handling matter. Checks to see if it's a date and time. That's all it's doing. So important stuff that's going on here in order to get us some of the pieces that we need to kind of move this puzzle forward. All right. There are a couple other things that will be needed. So got to do register, and the one last thing that we really have to do is one more function within this group of methods as a minimum. So we construct the instance of the class and get arguments in. We register the coordinates and set the status for ready. There's one other one that we need to do, and that is we need to describe another function that is another ID thing that we're doing. And this is we need to check what waypoint, check in the waypoint basically to that ID stick. So we need ID. We're also going to change up here ID. Down here, we're going to do ID. So there's a couple instances that we're going to have to update here to do ID. What this is doing is creating just the sum total of the information so we're going to have the ID stick registered to the person. We're going to, when we register it at a waypoint, we're going to add information to it, and we're going to do a check waypoint. This is more for error handling purposes, I think, really, than anything else. So it checks the waypoint data. it has to check the waypoint data by getting the course information. So how do we actually do that? You need to go get the course. And ID course info. So we need to get course info. We need to update the actual stick itself. So if it's valid, we need to update the stick. And we need to store this in a couple pieces of information. So we need the ID, we need the number. This is going to pull a few things in. So it's going to have ID and this I think is actually going to be it's not auto-filling now, which is very interesting. So we're looking to see what we need into this. This is going to be one that we're going to set up internal. Yeah, that's probably a really good way to do this overall. So waypoint num. In order to do that, we need to set up we need to set up the arguments, or we need to make some changes to the way that they run because of how they're going to be used internally. So arguments also has to have an end so that it knows when we're done defining properties of things. ID, this is some more sort of on the error handling side. To make sure we have what we need. So we made reference to the fact that we've got to be careful about how we handle these. There's a lot that goes into this. But we got to be careful about how we handle these, because this is going to change if we get basically bad information in to this function. We're going to have bad information coming out of this function, and there's some reasons why we want to do it that way. We want to make sure that it's using the correct data types so that we don't get strange compiler errors trying to have all sorts of formatting issues fighting each other, etc. So we're going to get this course info, and we're going to store some of this information into an array with these variables. So we're going to store that information with, so we got to have this. Update status is what we're going to be using to do that. So we're going to go back over to course in just a little bit and make sure that we have all of the things that we're going to need there. This is going to use the ID in order to store to that, and this waypoint num that we're using. And they're all going to work together to make sure we can do one little test. And so if there's multiple different courses running at the same time or something like that, people are on the wrong course, people are lost, they're, whatever the case may be, who knows. To add a little bit of robustness, you're going to do an if to see, we're going to say this value that we're using, a double and operator. You can use a single and there, but a double and is going to be a better habit to have, because that's going to be more C++ like in the operator's structure, so that you have an idea what's going on there. So we need this test, and what is okay. Okay is check waypoint of C, ID, and N. So we've got to put that in up here. So we're checking this to see, are we actually going to be doing, are we actually in the range? So it's going to continue to check throughout this. So that's our actual check. Then the stick, remember, we need to update the time for this waypoint. So how we do this is I've lost my autofill half the time. That's why I don't rely on it. It can save some time when it's working correctly. It won't always work that well or that nicely. So date time is another function for data type, and it stores the data type in a date. Now is a specific code for whatever the time is right now. Time including year, month, day, hour, minute, second. So all of that gets stored to timestamps. Then it needs to tell the participant when it's done. This is effectively the remove your card. You've now paid for this thing that you can't afford because nobody can afford anything. This is essentially what that line looks like. So this will print out the timestamp being updated. And this gives us what we need in check waypoint to be able to access this. The problem is this isn't going to know what signal is. So if you try to do help on signal, it's going to guess signal processing toolbox. Okay, so we need, we also need update status in there. So we need a function to do this. We need a function to do this. Because if you look on this, it's going to go, nope, I don't know what this is. So we need to write those. So when we need to do more stuff, this is the main method section. So after that method section is done, we need another method section. Be in the habit of opening and ending your sections together when you go to create them, because reasons. So we're going to need to create if we can spell correctly, signal and we're going to need another the update status. So we're going to need update status. We're going to need signal. So this is also going to need information from ID and this OK. So there's a couple layers and levels of what we need these things to do. So what fundamentally is signal doing? Signal is it responds to the user like a noise or haptic feedback. The buzz or beep or whatever from a terminal when you pay something is an example of this. For all these details. All right. So, the way that this is going to inform the user is this okay is this status. We're going to come back to what that looks like. Because we've got our register. We've got a couple of other pieces of the puzzle. We're going to use, we're going to define this, okay, in the course using information that we're going to pull over there. So it'll make a little bit of sense when we go to pull all of this together, because okay has to come from somewhere. Since we're not generating it here within ID Stick, we're actually going to be generating it in course. I'm going to go ahead and save this in our progress. I'm going to keep writing some of this because we know broadly what it needs to do. We know broadly what this needs to do, but we want to make sure that we've got all of our moving pieces in place. So this needs to just do stuff to let the user know what's going on. So the way to make this make sense is if we're okay, meaning if we pass the check that makes sure, hey, this is on the right course, essentially, because this is leveraging up here this check waypoint, but the check waypoint has to be defined inside the ID stick. The course has to validate the ID stick is on the course and part of the right course. They're not lost, et cetera, et cetera, et cetera. There's all this other stuff going on here. So there's a lot to be done. But what this is going to do is, if this is okay, and the ID stick is on the right course and it's a valid waypoint and all of that stuff, if the status, when we update status, this guy, status, if we update this status, we want to be ready. If it's ready up here, if that is ready, this is why this is a, like I said, this is probably going to be a multi-day project, because this is so many levels of things that we have to do kind of all at the same time. If this is, so double equals meaning comparable to, if it's comparable to, if it's the same as, has to be the same case, title case, lowercase. So if this is ready, then we do stuff, else end. We can use the display feature. Dr. K uses this quite a bit. If it's okay, if the status is ready, then so this is going to be a double operator. The other condition that's acceptable here is if status equal done, meaning they've finished the course. So either the stick is ready to be updated or the stick is now done. Then do this thing. So 2 beeps for acknowledge, 1 beep for fail. Else display. So this if needs 1 more condition. So if it's not okay, which is this else case, display beep. Or this one would be buzz for not working. So that's your buzzer, error, things like that. So this is mostly an error handling function that's going to give us the ability to give the user some kind of feedback on how this all would actually work in practice. So there's a couple more things that we need to do there. This at least gets us a pretty good start. So we are going to do update status. This we also need to write, and what we can do is we can make sure this has what it needs. It needs that waypoint num that we're going to be using in order to do the actual update of this. And so we'll have to go back through and double check our we're gonna have to double check all of our spelling and case usage and sort of all of the rest of this. But this is a relative ton of information that we're throwing at you. So let's do kind of a quick review over where we are. We've got ID stick as our class. We have the properties that we're going to be using, and we have some data types associated with those. We have the constructor to build what it is that it's doing, and it's storing information to ID. ID is important because it needs this information. There's also going to be register storing information to this class, the participant, so the name, course info, the timestamps, the status, especially the default is going to be ready. So this is why we set the default status that way. And then signal we've just set up and defined down there. So we need to be able to include that in the register. So we have to define all of these things to make sure that the code knows what it's doing. So we're then checking waypoints and seeing what's happening. But the way that these object-oriented programs work is it's not really only executing the program linearly from top to bottom. So we've discussed this a little bit, but not completely in depth. The reason we need all of these functions is it has to register, and then it has to check waypoint. Well, then it has to use signal, but then it has to use update status to get the thing to do the check waypoint and then to do the register, because that all has to feed up into the registration data so that the ID stick can output the information, and the ID stick needs to check in with the course. And so the course we're not completely done with either, but this is some of the levels of information handling that we're going to be doing in here. So there's a lot of information changing hands and moving around here. So this is where we're at as of today. We did get Signal built out in order to get the statuses done and ready and make all of that work. So there's a lot of levels and layers of these kinds of things. And this is examples of how to actually take information. We're going to continue working on these. We're going to continue working on the course especially. Let's take a look at how far that got. So we have the course defined. We have our properties. We have some variables associated with those. We're going to build a constructor here, and we're checking to see if there's enough arguments in. Otherwise, we're throwing an error. So we are starting to do some error handling in our code now. The next part is going to be actually building out these other functions for the course itself. So there's a lot of moving pieces still, but in order to keep these lessons digestible, where you can actually get caught up and do these things, the way that these would be happening in person is half and half, and we'd be building this out live with you guys able to follow along. So there'd be a lot of pauses and breakups. So that's why I'm recording these the way that I am, is trying to make sure that the lesson itself keeps moving. You guys can pause, get caught up, go back, re-listen to stuff, and get as much out of this as you can. So we've got another couple days of working out this concept of object-oriented to make all of this work a little bit better. So I'm going to cut this lesson here. We're going to pick up and we're going to finish out this update, and we're going to finish a couple other pieces of the puzzle here, finish developing the actual course code itself. So that's even though we haven't written the functions, the course is pretty straightforward. We're just going to be storing the information and then calling a couple things, checking whether or not the data is numeric or a string, and if it is sensible, in order to do the error handling on the course side, so that we can have code that's not just only going to work if everything is entered perfectly. We're going to be able to do some checking and some error handling and outputs like we haven't been able to do. So there's a lot of pieces to this. So we'll catch up in the next one.